Here we go. We are continuing on in our chapter about solutions. This is the third video. In this chapter, we're going to actually get our calculators out and start to do some calculations involving solutions. All right, we have talked about a solution. You have some amount of solute put into a solution or a solvent, making up the whole solution. And then we can calculate, well, how much solute do you have per amount of solution? All right, so we're going to be looking at these calculations. The first slide here, okay, we're going to start with a new term, molarity, okay? And molarity is how chemists often talk about the concentration of a solution. And we do it in terms of moles of the solute, okay, that's the thing present in the smallest amount, divided by liters of the entire solution. Make note, it's not liters of the solvent, but the entire solution. So molarity is given the symbol of just a capital M, and it stands for moles per liter. Now, we've talked about concentration before, and you can talk about it in different units, but we'll often use it and get it to moles per liter. A couple examples here. You can see some flasks here, some volumetric flasks. They all have the same volume, okay? They're all 1 liter, 1,000 milliliters. And you can just add differing amounts of the solute. In this case, it's sodium chloride. If you add, let's see, 29.22 grams, okay, you can convert that to moles. And then you take that moles divided by 1 liter, and you end up with a 0.5 molar solution. Now, if you double the amount of solute, okay, so we have 58.443 grams of sodium chloride, and you put that into a 1 liter solution, now you have a 1 molar solution. And if you double that, now you have 2 moles per liter, which would be a 2 molar. The more solute you have, okay, so the more amount in grams, the more moles you have, the more concentrated your solution. So we'll be able to do calculations here involving finding moles, dividing by total volume of solution to get the molarity. All right, let's do a practice. And this one says, how many moles of sodium chloride are there in 200 milliliters of a 1.00 molar sodium chloride solution? And then the question says, oh, and can you also get to grams of sodium chloride? All right, couple things. When you are given molarity, and you actually have to do a calculation with it, I want you to be able to recognize that writing 1.00 m, okay, and that stands for molarity, is the same thing as writing 1.00 moles per liter. All right, those are identical to each other since molarity itself stands for moles per liter. So when you see that big M, you think, hey, this is a conversion factor between moles and liters. Conversion factor. Just like we were using the molar mass, okay, in grams per mole to go between grams and moles, we can use molarity now to go between moles and a volume in liters. All right, so when you are given a problem like this, okay, we can identify what we have. This milliliters, this is a volume, okay, and we have molarity, which is moles per liter. I can quickly see I have a milliliters and a liters, so I'm going to need to convert my milliliters to liters. And if I do that and then I multiply, I can get liters to cancel out. So here would be the game plan. Milliliters of NaCl to liters, and then to moles. And the next part is asking for grams. Okay, we'll stop and then recalculate, but then you can easily go from moles to grams of something knowing the molar mass. All right, so a couple steps here. 1, 2, and 3. All right, and let's get this set up, starting with our milliliters. And ask yourself, in between milliliters and liters, what is bigger? And you would say, hey, a liter is bigger, so you put the 1 by the liter. And then in 1 liter, how many milliliters can you fit? And that is 1,000. I want milliliters on the bottom, so that cancels out. And then I can use the conversion of the concentration. I see 1.00 molar, which I know is moles per liter. my goal is to get to moles, so I'm going to put the 1.00 moles for every 1 liter NaCl. And then I'm going to stop here since the first part just wanted that in moles, and then we'll do the second part in a second. So if you do this math, you can see that milliliters will cancel, the liters cancel, and we end up with 0.200 moles of sodium chloride. So if you have 200 mils of a 1 molar solution, you have 0.02 moles of sodium chloride. We can take this, and then we easily can go, this is back from previous chapter, 0.200 moles of NaCl, and we want to set up this conversion. Oops, that was a silly line. We want to set up this conversion so we end up with grams of NaCl. How do you go between moles and grams? That's the molar mass. And where do you find the molar mass? You need to get your periodic table out. Look up the molar mass of sodium, which is right around 23, and you look up the molar mass of chlorine, which is around 5.45. I have a couple more sig figs here. I have 58.443 grams of NaCl for every 1 mole NaCl. Do that work, and I end up with 11.7 grams of sodium chloride. So this solution contains 11.7 grams of sodium chloride. All right, I think that is good. I think we have another one to practice here. A lot of the time students are just trying to piece together, hey, what variables am I given and what am I trying to solve for? So let's look at this one. Again, we're sticking with sodium chloride. We got that one down, so we're going to keep going with it. And can you help me identify what is given, where I'm trying to go, and what conversion factors I need to get there? Let's read the question carefully. How many milliliters? So we're asked for a volume in milliliters, and we're given a 1.5 molar solution, and this is of sodium chloride. Do we need to obtain 100 grams of sodium chloride? So we just did it where we found that we had 11.7 grams. This time we need to get 100 grams of sodium chloride. All right, so other piece of information. This would be our mass of NaCl in grams. And we're given 1.5 molar solution. That's how you'd read it. You would read it 1.5 molar. Now, what I said, when you're doing calculations, you think of that concentration in molarity as a conversion factor, because when I see 1.5 molar, I know that's 1.5 moles per liter. All right, so starting with our grams, and students often will say, hey, do I start with the 1.5 or do I start with the 100 grams? I would usually say you want to look at your units. I would start with the thing with 1 unit and use the thing with 2 units as one of your conversion factors. So use the concentration to go between moles and liters. All right, so if we're starting with 100, oops, I'm going to actually just write grams. We're going to start with grams of NaCl. I don't want to get ahead and put in numbers. I want to get our game plan first. All right, starting with grams, before I can use that concentration to get to a volume, I need to be in moles, since it's moles per liter. So I can easily get to moles. From there, now I can use the concentration as a conversion factor and get to liters. And the question asks for not how many liters, but how many milliliters. So we're kind of doing an opposite little go as we did in the previous problem, but then we can get to milliliters. So this is a 1, 2, 3-step process. Let's try to get this worked out correctly. We have 100 grams of sodium chloride that we're going to start with. We already have found the molar mass in the previous problem. That relates grams to moles. It came from the periodic table. It was 58.443 grams for every 1 mole of the NaCl. Then once we're in moles, we can use the conversion factor to get to our volume. In this case, we want moles to cancel. So I'm going to write the 1.5 moles on bottom for every 1 liter up on top. It's a lot of writing of both units and what you're talking about. It's important to do the whole time. And then lastly, we can get from liters to milliliters. We want liters to cancel. Milliliters up on top. You can check units that are canceling here. Grams cancels, moles cancels, liters cancels. The only thing left is milliliters. And when I get this on my calculator, I have 1,100, that's a comma, 41 milliliters of NaCl. So in order to get 100 grams of sodium chloride in a solution that is 1.5 molar, I need to get 1,141 milliliters of that sodium chloride. All right, more practice of those would be excellent. But let's talk, now we can actually do the work, okay, to do this. Let's talk about what that looks like when you're actually making it. So if you need to go into the lab and make a solution from scratch, and you know the concentration that you're trying to make, you know the volume that you're trying to make, you need to figure out how many grams, okay, because you don't go and weigh out moles, you have to get to grams. All right, so this is an example. It says, how would you prepare 500 mils of a 0.15 molar sodium chloride solution? You see the volume, okay, and you see the concentration, which is moles per liter, and we can do the work. This is just like we did in the previous 2 problems, so I have it set up right here for us. You start with the volume, okay, I converted it. Okay, a fast way of going from milliliters to liters is you divide by 1,000, so you move the decimal place over. So we have 0.5 liters, and then use the concentration as a conversion factor to get to moles, and then we can go from moles to grams. So if you are answering this question, you say, hey, you need to go weigh out 4.4 grams of sodium chloride. Now, that's how much you need to get. How do you actually go about doing this? So, important thing to kind of make sure you can understand the difference. I have 2 statements here. Can you read them both and understand why one's different from the other? All right, so they both start like this. Add 4.4 grams of sodium chloride to a flask, and then add 500 mils of water. Okay, that's the first statement. The second one says, add 4.4 grams of sodium chloride to a flask, and then add water up to the 500 milliliter mark on the flask. All right, and this is a volumetric flask. What's the difference between the 2? Okay, in the end, you probably are adding right at 500 mils. However, when you are making these solutions, you have to take into account that sometimes the solute takes up some volume as well. Okay, and when you mix, okay, sometimes the volume adjusts. So you don't want to say, okay, so please cancel out that first one here. All right, ready? We're going to X this one out. This would not be correct. The second one is the one you want to go for. You want to say, I will add 4.4 grams of sodium chloride to a flask, and usually you would use a volumetric flask that has just a single line, in this case for 500 mils. Then you want to add water up. Okay, so you usually add about half the water, get it good and mixed and dissolved, and then add water up to the line. So the bottom of the meniscus is right there. So now you can all go and practice making different solutions, okay, and then testing it out, calculate the concentration of the solutions that you've made, and you can do it properly. I think I had one more practice question, okay? And this is a good one for you because you kind of can see you're given the volume and you're given a concentration again, and you're asked for a mass of sodium carbonate. So we've done this, okay, and I'm probably going to tell you to think about it and stop, but you have to realize that stuff from previous chapters, such as nomenclature, continues to stay on in this class. So for the final exam in this course, you will still need to know your nomenclature. All right, so I'm going to let you set this one up, and then I'll come back. Can you find the mass of sodium carbonate needed to make 450 mils of a 0.975 molar solution? All right, welcome back. I hope you were able to work this problem out on your own. One of the hardest things was making sure that you knew what sodium carbonate was. So carbonate, polyatomic ion, CO3 -2, sodium, alkali metal, +1 charge, so you needed 2 sodiums for every 1 carbonate. So correct formula, Na2CO3. Find the molar mass. That I got 106 grams per mole. You have your setup. We're going from milliliters to liters to moles to grams, okay? And we have our conversion factors figured out. The first one's just a milliliter to liter conversion. How do you go from liters to moles? Conversion factor there is the concentration. We were told it was 0.975 molar, which we know means 0.975 moles per liter. This time we wanted the moles on top so that liters cancels out. And then lastly, once you're in moles, go to grams using the molar mass. We want to multiply by the 106 grams, and then moles will cancel out. And I got 46.5 grams of sodium carbonate is needed. Okay, you go weigh it out, and then you add that and add the volume up to 450 mils to get this solution that would be 0.975 molar. All right, more practice at this would be helpful, so do some more problems, and we're going to look at another way to make a solution of a certain concentration in the next video.